right, Unit 8, test review. This is a test all about quadratic equations and functions and parabolas and that kind of stuff. This covers all of the food worksheets we did over the last couple weeks. Starting out here, numbers 1 through 9, they all use this parabola over here. Our vertex. Vertex is the tip of the parabola, the highest point or the lowest point, the maximum or minimum. In this case, the maximum right there is -3, 4. The axis of symmetry is the vertical line that splits the parabola in half, makes it symmetrical. That axis of symmetry is always named by its equation, which is always x equals, and then however far over it's shifted. In this case, it's -3, the left 3 units. Also, you can use the x value of your vertex. Always going to match the axis of symmetry. The roots, the zeros, the x-intercepts, and solutions, which aren't on here, are all the same. They're all these x-intercepts where the line crosses the x-axis. In this parabola, we have -1 and -5. So, zeros, same thing. X-intercepts, same thing. -1 and -5. The domain is all of the x values that are used up by this parabola. X values being left and right. X-axis, it goes left and right. This parabola goes on forever and ever to the left because of that arrow, and forever and ever to the right because of that arrow. There are no boundaries on the left or right, so our domain is all real numbers. The range, similar to that, but a little different because it does go down forever, but it has a boundary up top at that maximum point, which is 4. So it's not going to be all real numbers. It is everything that is less than 4, all numbers below 4. The way we say that is y is less than or equal to 4. Number 8. All right, number 8, talking about the vertex form of an equation. If you know the vertex, which we just found out was -3, 4, and we know an ordered pair, which they're giving us -1, 0, we can use those 2 points to find the equation of this parabola using the vertex form of an equation, which is on your formula chart. It's y equals a parentheses x minus h squared plus k. We can plug in our vertex, which is h, k, and our ordered pair, which is x, y, and find a. Once we find a, we can plug a in and the vertex, which is number 9 over here, to get the actual equation. But first, we got to find a. Y is 0. We plug that in there. Equals a parentheses x is -1 minus h, which is -3, squared plus k, which is 4. We got minus negative, that changes there. So -1 plus 3 is going to turn out to be 2. So we end up with 0 equals 2 squared is 4. So 4a plus 4. That's our equation. Minus 4 to both sides. We get -4 equals 4a. Divide, and a equals -1. On number 9, we can use that a, and we can use the vertex to find the standard form of the equation. So we have y equals a minus h squared plus k. We're going to plug in not x and y. The equation has to have x and y in it. We're going to plug in h, k, and a. So y equals a -1 x minus -3 change squared plus 4. The way we simplify all this is by FOILing x plus 3 squared first. So x plus 3 x squared plus 3x plus 3x plus 9 gives me x squared plus 6x plus 9. Distribute this negative 1. Gives me negative x squared minus 6x minus 9, but I also have this plus 4 that comes down there. I can combine these like terms here, and I get x squared minus 6x, sorry, negative x squared minus 6x minus 5. All right, solving quadratic equations. We have learned 3 methods to solve quadratic equations. Factoring is what we learned last unit. That's where you do the x box, you rewrite the binomial factors, set them equal to 0. The quadratic formula, that's the big square root formula on our formula chart, and graphing. Graphing is probably the easiest, but it relies on your calculator, and you have to be able to graph it on the graphing calculator. All 3 of them have their benefits on certain equations. I'm going to show you one of each method, starting with factoring on number 10. Factoring is where we look at the x box. First, we check for a GCF. Well, back up. First, it has to equal 0. So we're good here. On some of these other ones, we're going to have to fix because they don't equal 0. But on number 10, we're good. Check for GCF. I can factor out a 3 of all these. So 3x squared plus x minus 2. So this is what I'm actually factoring, x squared plus x minus 2. That gives me negative 2 up top and 1 on bottom. So when I multiply 2 times negative 1, that gives me negative 2. If I add 2 times negative 1, that gives me 1. So my factors, x plus 2, x minus 1. We bring down our GCF of 3, and it equals 0. This is where we can think about how all of this stuff multiplied together equals 0. That means that either x minus 1 or x plus 2 has to be 0. Now this can't be 0 because it's 3, so one of these has to be 0. Either x plus 2 is 0 or x minus 1 is 0. Solve both of those equations, you end up with x equals negative 2 or x equals 1. So that is number 10. That is factoring. This works well on some problems, but not all quadratic equations are factorable. So this is not really a reliable method. Number 2, we're going to solve that one by graphing. In order to graph, we have to have it equal 0. So I need to cancel that out. 2x squared minus 2x minus 40 equals 0. Go to your calculator. We have 2x squared minus 2x minus 40. Yes, minus 40. Our solutions are the same as roots, zeros, and x-intercepts. So we're looking for the zeros here. These are pretty easy to just look and spot counting. If it were decimals, then we would have to go to either trace or analyze graph. Menu, 5 is trace, graph trace. We can move left or right until it stops at the 0 there, which is negative 4. Or the other 0, which we go all the way around to the right, which is, whoop, past it, 5. So those are our two solutions. If we want to do it the other method, analyze graph. Option 6, find the 0, that is 1. Click in the middle. Go to the left, we see that it's -4. Go to the right, we see that it's +5. Those are our two zeros. So the solution here, -4, comma, 5, or -4 and 5, in any order. Those are solutions using the graphing method. Quadratic formula. Let's see, which one do I want to use? I'll do number 13. Quadratic formula, on your formula chart, it is x equals -b plus minus square root of b squared minus 4ac over 2a. Equation down here has to be in, I'm going to run out of time. I'll have to come back to this in a little bit. All right, quadratic formula. We're going to solve number 13 using the quadratic formula. The equation has to equal 0 first, so make it equal 0 first. 2s squared minus 3s minus 2. That's my a, that's my b, that's my c. So, I need some space here. What can I work with? We'll figure it out. We'll just do it over here. -b is going to be -3, so +3 plus minus square root of b squared. -3 squared is 9 minus 4 times a times c. So 4 times 2 times -2 is -16. That is, I'll go ahead and change that now. Divided by 2a, which is 4. Next thing I'm going to do is square root whatever 9 plus 16 is. 9 plus 16 ends up being 25. The square root of 25 is 5. So I have 3 plus minus 5 over 4. I'm going to split that into two equations. 3 plus 5 over 4. 3 minus 5 over 4. That gives me 8 over 4, which is 2. This gives me -2 over 4, which is -1/2. So those are my two solutions, 2 and -1/2. The rest of these can all be solved using one of those three ways. Factoring only works sometimes. I would not really rely on factoring unless the problem is already factored for you, like on number 12. The quadratic formula works. It's a little bit of a process, though. It works for everything, though. Graphing, probably the easiest way to do these. Make it equal 0, graph the equation, find the roots, and you got your solutions. All right, shifting parabolas. We have our quadratic parent function, which is y equals x squared, which we know looks like that right there. All the changes that we can make to that equation, shift it up, down, left, or right, or narrow or wide, or flip it upside down. +1 shifts it, +1 shifts it up 1. The 5 here makes it narrower. I'm going to say narrow and shifted up 1 unit. If you didn't know that, you could check your notes, or you could just graph that equation and compare it to the quadratic parent function. Over here on number 17, +2 goes up 2. +5 inside the parentheses shifts it to the left 5. The -4 flips it and makes it narrow. So those are the 4 changes. Number 18, 1/2. makes it wide. Minus 6 in the parentheses shifts it to the right. 6 minus 5 shifts it down 5. All right, moving down to number 19. We have a catapult launching a stone in the air. This equation describes the height of the stone as a function of time. Whoops, that should be a t there, not an x. It asks us a bunch of questions about how high the stone is based on certain amounts of time. So first thing we have to do is graph this equation, negative 16x squared plus 135x plus 6 in our calculator. You can't graph t, so you got to use x. It gives us this parabola here, which we can't really see much of. But if I trace menu 5, 1, it gives me all the points I need to see. So, how high is the stone? The moment it is launched. That's its starting point. So at 0 seconds, the stone is 6 feet in the air. So, 6 feet. There we go. How high is the stone after 4 seconds? We can trace left and right and move up to 4 seconds. If it passes over 4 seconds, or if we just want to get there quicker, just hit 4, enter. It goes straight to 4, which is 290 feet high. So, 290 feet. How long is the stone in the air? We need to find when the stone comes back to the ground. And we'll keep tracing all the way down and find the 0 right there. It's in the ground at 8.48 seconds. Don't worry about this. That's just a weird way of showing 0. It has to round it very slightly, but that's 0 for all we care about. 8.48 seconds. What is the highest the stone will reach? And how long is this? Oh, wait, no. Wait, what am I reading? How long is the stone in the air? I wrote the same question twice. Number 22, what's the highest the stone will reach? We got to find the vertex. Go back up to the vertex. 4.22 seconds. The stone is 291 feet high. So, 291. This was supposed to say how long is it until the stone reaches its highest point, but oh well, we've already answered that one right here. All right, the last two, number 24 and 25, very similar. What quadratic equation passes through the points in the table? To find the quadratic equation, we're going to use our little scatter plot technique we've learned before. We haven't done it yet with parabolas or quadratics, but we did do it with linear equations and exponential equations. So it's the same thing here with quadratic equations. We need to go remake this table on our calculator. So, new document, list and spreadsheets, we're going to put in all of the X and Y data here. You're going to name the columns first, X and Y. Then you can put in the numbers 0, 1, 2, 5, 10, 19. 0, 2, 5, 10, 19. When I go to add a page, I'm going to add data and statistics. Option 5, that'll give me the scatter plot. Remember, we have to add the X label and the Y label, and that should make some sort of a little parabola, at least part of one. Find the equation, we're going to go menu, analyze, regression, and then here's where we have to think about what kind of equation we're looking for. Before we used linear, which is option 1, and we used exponential, which is option 8. Well, now we're using quadratic, which is option 4 and it gives you your equation, 2x squared plus 3x plus 5. So here, y equals 2x squared plus 3x plus 5. Number 25, you can do the exact same way. Test is Friday. Good luck.